Thanks, Steve. Hi, everyone. Very happy to be here with you all. Who uses Git? Okay, that's good. So for anyone who has ever used Git, did you ever get to a point where you said, oh, what did I just do? Okay, that seems to be I guess, full overlap. Okay, so what we're going to do today, we're going to talk about undoing things with Git. So we can rewrite history with confidence, and instead of thinking, oh my God, what did I just do? Oh my God, rather finding it more of a nice challenge that we're equipped to solving. So before we start, I would like to share with you a really cool XKCD comic that I really like. You guys familiar with XKCD? How many? Okay, some of you. Whoever is not, I really highly recommend it. It's a really good comic. And this is a pretty old one. And you can see someone here telling, this is Git. It tracks collaborative work on projects through a beautiful distributed graph theory tree model. Cool, how do we use it? No idea. Just memorize these shell commands and type them to sync up. And now comes the interesting part for us. If you get errors, save your work elsewhere, delete the project, and download a fresh copy. Which is advice that I've received multiple times by quite experienced people. And it got me thinking. I mean, you can find a lot of tutorials on the internet telling you how to get out of bad, weird, scary situations you might have gotten yourself into with Git. But what I found most of them lack is the intuition behind it and tools as to understand the situation and then get yourself out of it, rather than memorizing some shell commands and typing them and hoping that they would fix the situation. So what I want to achieve today, what we'll do, we will better understand the internals of Git. And the previous time I was here, and it was also recorded, so if anyone here missed it, you're welcome to watch it. We talked about the very internals of Git, and we built a repo from scratch. So we're not going to focus on that today, but we will understand how Git works. We will acquire some useful tools and commands that you will feel very comfortable with after this talk, and you'll be able to apply. We'll improve our intuitions regarding Git, so it won't be scary, but rather fun, interesting, challenging. And we'll have fun, because learning Git internals is fun. You ready? All right. We'll start first by understanding how we record changes in Git. Now, in order to save time, I won't be typing most of the commands myself. I typed them previously, and they're going to be here on the presentation. So this is our shell, and here are 3 different states each Git repository has. It's very useful to think about Git as a way of recording changes in time introduced to a file system, to a directory. And for every repository, we can look at 3 different states. One is called the working directory. That is a directory on your file system that has a repository associated with it. And a repository is just a collection of commits and a few other things. Mostly it's a collection of commits. A commit is a snapshot in time of the working dir. That's it, okay? So when we think of commits, we can think of different versions of a directory, its subdirectories, and files. So we have the working dir. Then we have the index or the staging area. These 2 terms are interchangeably used very widely within Git. And by saying within Git, I mean any tutorial you would see, even Git source code. They're so interchangeable, I'm going to use them both, so we feel comfortable with both of them. So the index, or the staging area, is our playground for the next commit. So I can work and do whatever I want with the index, add things to the index, remove things from the index, and then, only when I'm ready, I commit it to the repository, which creates a snapshot in time of the index, to be accurate. And last, we have the repository that, as we said, is a collection of commit objects. So let's start a repository. We use Git init, and we have a new repository. Once we hit Git init, there is a new folder in the file system. Does anyone know what folder that is? .git, correct. So we have a .git folder. In the previous talk, we talked what it includes. It's not going to be the focus today. Again, if you're interested, you can check out my YouTube channel. I have a lot of tutorials about Git there, and also the previous talk we had in Code and Coffee. So we have a .git folder. Now I wrote some text, hello world, into a file called one.txt. Where is it now in those trees? The working dir, correct. It's in the working dir. It hasn't yet been introduced in the index, right? So in order to stage it, to add it to the index, we use git add, correct? So I can use git add one.txt. So now the index includes this file. And to commit it, I can use git commit. And git commit tells a few things. The beginning characters of the SHA-1 value of the commit object, which is a pointer to a tree showing the entire working tree. In this case, it's going to be only this file within the root folder, timestamp, author, and stuff like that. So far, so good? OK, cool. So we have commit 1. And when we have commit 1, we also have a branch, right? So Git, by default, creates a new branch, nowadays called main by default. And a branch in Git is just a named reference to a commit. That's it. It's a reference with a name, and it points to a commit. So by default, we have the main branch. And if we have multiple branches, how do we know which branch is the active branch, the one Git is currently on? Sorry? Git branch is a command that tells us that, correct? But how does Git know what branch it's currently on? It has a file called head, which points usually to a branch, which then points to a commit. Under the hood, this is just a file. It includes the name of the branch with some prefix. Again, I talked about it in the previous talk. For today, it's enough to understand we have head, which is a pointer, usually, almost always, to a branch. And then the branch is also a pointer to a commit. So this was the first commit. Now I want to create another one. So let's create a new file. So echo second file into 2.txt. Where is it after hitting enter? Working there, correct. I'm going to stage it. I'm going to use git add, correct. So now it's staged, added to the index. And now I'm going to use git commit. Now git commit does two things. One, it creates a commit object. So there is an object within Git's internal database of objects with a corresponding SHA-1 value that we see there that is going to be created within the repository. This commit also points to the parent commit. That is the commit that head was pointing to when we wrote the git commit command. So first thing, we create a commit object with a pointer to the parent commit. Second thing, what still needs to happen and happens every time we git commit, we move the main, right, the active branch, in this case main, the active branch to point to the newly created commit. So again, git commit does two things. It creates a commit object, and it moves the active branch to point to the newly created commit. Now if I use git log, for example, it will go to head to know the active branch. The active branch is main, pointing to commit 2. Next, we can track it back to commit 1 using the parent chain. So each commit points to its parent commit. So far, so good? Cool. So now we're talking about Git Undo. How do we undo those changes? And one of the most useful commands that is so clear in understanding once we understand those 3 directories is the first tool I'm going to introduce today. And we're going to gradually build our toolbox. So currently it may have a hammer or other useless things for Git undoing. So we're going to add some new tools. So what I'm going to do now is undo the process of introducing a commit. So the very last step I did was to commit, which actually means 2 things, right? We created a commit object, and we moved the active branch. So to undo that, we're going to use the command git reset. with the switch minus minus soft. It has 3 switches. We'll cover all of them. So minus minus soft. And this syntax means the parent of head. It means go to head. Tilde 1 means to the first parent of head. If I had more than one commit here in the chain, let's say there would be, let's say I had commit 3. I could use head tilde 1 to get to commit 2. Head tilde 2 would go to commit 1, the parent of the parent. So by using git reset minus minus soft head tilde 1, what I'm actually asking Git to do is to change whatever head is pointing to. I'm using star head like a C syntax here. Okay, so whatever head is pointing to, which at this point is main, right? It used to be main. Move that to point to head tilde 1. So what Git would do is only change the pointer of main from commit 2 to commit 1. Does that mean the commit object is deleted? No, it's not deleted. It still resides within Git's internal database of objects, but it's no longer reachable from the commit history that we have. If we use git log now, git log will go to head, then main, then commit 1. No pointer to commit 2, right? So we don't see it anymore, but it's still there in the internal database object. If I push the current history now, if I use git push, it will not be pushed to the remote, but it still exists on my local copy of the repository. Okay, so after I did that, what about 2.txt? Is this file, does it exist in the active commit? No, correct, because the active commit now is commit 1. Does it exist in the staging area? Yes, we did not erase it from the index. So what git reset minus minus soft does is undoing the last step of committing a change. It only changes whatever head is pointing to. That's it, changes the pointer. So commit 2, for us, it's no longer reachable, so we may think about it as it doesn't exist, though it does exist locally, but for us, we just undid it. Okay, so that was git reset minus minus soft. Let's create the commit object again. So I'm going to use now, or before git status, we can verify that it's indeed in the index waiting to be committed. If I use git log, what is the commit I'm going to see? Commit 1, right? And there is no parent to commit 1, so that's where it stops. Cool. So now I'm going to use a new commit. So I'm going to create new commit, git commit 2.1. Now why is that commit 2.1 and not commit.2? Oh, sorry, commit 2, like before. Why is it a different commit object? I mean, the index is the same as it used to be, right? It has both 1.txt and 2.txt, correct? But the commit object is going to be different. Even if I did write here commit 2, it would create a different commit object. Why is that? Objects, right, but the commit object itself includes the reference to this directory. So it would hold only these objects. It doesn't hold any additional objects. But there is one thing that is obviously different. Timestamp, correct. So the timestamp of the commit is different, right? We committed now. So we get a new timestamp, thus a new commit object. So just so it's clear on the whiteboard that we have here, I'm not going to rewrite the arrow every time, but actually we have commit 2, which is unreachable now. That points to commit 1, and also commit 2.1 that is going to be reachable, right? Because commit does 2 things. Git commit creates a commit object and changes the active branch to point to this commit object. So Git changes the pointer to point to commit 2.1, which then points to commit 1. Okay, so we committed, we undid the last commit. So that was git reset minus minus soft. Now let's say I want to go even backwards and undo further. So the next thing we can do is use git reset minus minus mixed head tilde 1. This is, by the way, the default switch. So if you ever write git reset without specifying minus minus soft or minus minus mixed, or as we'll see in a sec, minus minus hard, it actually does minus minus mixed. Now I always write explicitly minus minus mixed because I want to know what I'm doing, and I want to make sure that if any time a lousy developer decides to change the default value, okay, I'm not affected. So I'm going to write git reset minus minus mixed head tilde 1. So this command starts just as if we used git reset minus minus soft, meaning it takes the pointer of whatever head is pointing to now, which is the main branch, right? And sets it to be head tilde 1, which is commit 1, right? This is head is pointing to eventually commit 2.1. Its parent is commit 1. So it changes the pointer to point to commit 1, meaning the 2.txt is not in the active repository, the commit that head is pointing to in the repository. So far, so good. Now it goes even further to the next step, which would be undoing what we did to the index, that is, changing the index so that it matches with the current head, the new head. So now head is pointing to commit 1, right, after the change. So if we change the index to match commit 1, it means that we're not going to have 2.txt in the index either. So we started the same as we did for git reset minus minus soft, and we moved even one step ahead to undo the staging stage, the staging step, to add something to the staging area. So undoing that means removing it from the staging area. If I want to create a new commit 2, which would be commit 2.2, what do I need to do now? So I want to recreate commit 2. It's going to be different because it has a different timestamp, right? I want to create a new commit 2, which would be identical in the state of the tree to the state of before. Right, I need to add 2.txt because it's not part of the index now, right? So I'm adding, yeah, go ahead.
Would it be git reset dash dash mixed head 2?
So head tilde 2, well, right now head points to commit 1, right? And commit 1 doesn't have a parent commit, so head tilde 2 is not valid currently, okay? And before that, we had commit 2.1, which actually pointed to commit 1. I said, I am leaving this here just to remind ourselves that this commit object still lives within Git's internal database object database. Okay, cool. So if I use git status now, we see that we're on branch main, and this file is untracked. Untracked meaning it has never been introduced to the index. Now we know it was introduced to the index, but we actually undid that step completely. So this file was as if it weren't introduced to the index at all. So to get a new commit object, you said correctly, we need to stage 2.txt again. And I'm going to use git commit. So we create a new commit object, meaning we'll have a new commit object commit 2.2. And what else needs to be done? Correct. Update main so that it points to the newly created commit object, commit 2.2, which then points to commit 1. Any questions so far? Yes, please.
Is the difference between soft and mixed flags that mixed also unstages the file in the staging area?
Exactly. That mixed, after performing the soft part, goes further and matches the index with head. In this case, it meant unstaging this file. You're welcome. Any other questions so far? All right. So let's move forward to the last switch for git reset. There are others, but these are the main three. That is dash dash hard, head tilde 1. So again, we start as we did before. We do git reset soft head tilde 1, meaning move whatever head is pointing to, which is currently the main branch, to point to head tilde 1, which is commit 1. So far, so good? All right. So we're moving the main branch. Next, we're moving on to the mixed stage. The mix stage matches index with head, the new head. That is, we undo the staging of 2.txt. Git reset minus minus hard goes even further and matches the, any guesses? Working dir, correct, with the stage of the index. In this case, it means removing 2.txt altogether, also from the working dir. Okay? So basically, to introduce a change to Git, we have 3 steps. We change the working dir, we change the index or the staging area, and then we commit a new snapshot with those changes. To undo, if we use git reset minus minus soft, we undo the commit stage. If we use minus minus mix, we also undo the staging part, okay? The staging of the new file or change that we introduced. And if we go further and use minus minus hard, we also undo writing the changes to the working dir. That is, after writing git reset minus minus hard head tilde 1, we got all 3 trees to match one another and match the state of what used to be head tilde 1, in our case, commit 1. So as if we erased any trace of commit 2. Even though we remember it still exists internally in Git's database. Any questions about git reset before we start applying it into real world scenarios? Yes?
So you're saying with the hard, in the past, I did something that deleted files from my working directory.
Right.
Is that what you're saying this does, the hard?
So git reset minus hard may delete files from your working dir, right? If the current state has those files and the state you are resetting it to doesn't have those files. It will delete things from your working dir in this case.
Okay.
Okay?
That's the disaster. Okay.
Yeah. Oh, what you're saying is that if I use git reset minus minus hard, I may be in trouble. We'll get to that later today. I promise. No worries. We're going to gain confidence today, not lose confidence. Okay, so, by the way, in this specific case, it wasn't really deleted. So if you play around with these commands, I use creating files and not other changes just to make it even clearer what's happening. So if you do that, you will notice that the file is not really deleted from the working dir in this specific case because it was never introduced to the index beforehand, so it's untracked in Git. It's an edge case, not something I want to focus on. What I do want to focus on is real scenarios. So in a real scenario, I write I love Git into love.txt, as we all love Git. I'm happy you all agree with me. Okay, so love.txt is in the working dir. I'm going to stage this and commit. That's cool. So now I have commit 2.3. Oh, sure. Actually, I didn't want to commit it now. It's not what I wanted to do. Okay, wait. So what happened? I used git commit. 2 things happened, right? I created a commit object, and we changed main. Okay, but now I just realized that was a mistake. Oops. What I actually wanted to do is write some more love words in this poem I'm writing before I commit it. What do? Yep. Cool, so I could git reset soft. So if I used to commit 2.3, it wouldn't really change anything, right? So where would I reset it to? Right, or commit 1 in this case. We have commit 2.3 pointing to commit 1, right? So I could use head tilde 1. I could actually also write the commit SHA of commit 1. It would be the same, right? So in this case, I used mixed because I didn't want to stage it either, but I could also stage it and then rewrite the staging. So in this case, it means that love.txt is no longer a part of the commit. That's sad, I know, but we'll bring it back. And main changes, and it's going to point to commit 1, correct? And as this is git reset minus minus mixed, we also undo the staging, meaning that love.txt is not going to be part of the index. What about the working dir? Is it still there? Yes, it is. Good. So now I want to add some other things that I love, like brief channel. That's my YouTube channel. So I add that to love.txt. And now I can stage and commit everything I wanted, and I get this clear, nice history of commit 2.4. This one only exists in my internal database, commit 2.4 pointing to commit 1. Okay. Easy peasy, right? Okay. Let's get a bit more advanced. Yeah, we're happy, of course. All right, so our toolbox. We've got a new tool called git reset with 3 different switches. And you will see that this command is super, super useful, and actually you can accomplish almost anything with it. It's not always the most convenient tool to use, but it solves almost any problem if you use it carefully. And for beginners, I usually recommend just use git reset for almost any time you want to undo something. Almost. Let's see another case. So now I created a new file called new.txt, and I staged it, so it's going to be in the staging area, and I'm going to create a new commit 3. So now I'm going to have, after that, head pointing to main pointing to commit 3, right? Which points to commit 2.4, correct. So this is my history now, new commit object, main pointing here. Oops. Actually, that's a mistake. I was on main, and I wanted to create this commit on a feature branch. I see a lot of nodding heads. Who made that mistake in the past? Okay, a lot of people, right? This happens all the time. Okay. Let's stay calm and see what we can do. There are 2 most important tools I want you to take today from this talk. The second is git reset. The first one is to whiteboard the current state versus the state you want to be. So in this example, this is our current state. We have commit 3 that main is pointing to, right? Commit 3 points to commit 2 points to commit 1, or 2.4. I'll say commit 2 for short. What is the desired state? What needs to be different there? 2.4 is where main is pointing to, right? What else? There's going to be a feature branch pointing to commit 3, and head is going to point to feature branch. So first thing, main will point to 2.4, right? This is the first change. Second change, we're going to have a feature branch pointing to commit 3. And head will point to feature branch, correct. If you can draw this, and you know how to use git reset, we're going to solve everything in a calm manner. Make sense? Good. So again, the most important thing is to wait a second, draw this out. I have to tell that many times, people have come to me and said, oh my God, I made a mistake, I need you to help me with Git. And I'm like, okay, what is the current state? No, don't tell me the problem, show me the current state. And once people draw this, and then they draw that, they don't need me anymore. It's amazing, I only ask questions. It's the easiest job in the world. Anyway, so this is the desired state. How do we move from the current state to the desired state? Things we may be able to do. Okay, so if we reset hard, it's going to change main, but I'm going to lose all the changes that I introduced here, right? And I want to use those changes, correct? So reset, soft or mixed, right, would leave the changes somewhere for me to play with. So with this current state, what I'd rather do is use -soft, because I want the exact stage here to be committed, right? The exact stage in this commit to be committed just elsewhere. So by using git reset -soft, I'm changing what? Main, correct, whatever head is pointing to, main, to point to the parent of commit 3, commit 2. This is blurred because it's still there, just not reachable, right? Cool. Now, what do I need to do? A new branch, right? So there are mostly 2 common ways to do that. One is with git switch -c. The other is git checkout -b. They're the same. Some people prefer this. Some people prefer that. So in this case, let's use git switch -c. Feature. What does that command actually do behind the scenes? Okay, right, it points head to feature, but even before that, it creates a feature branch. That is, it creates a new pointer. Behind the scenes, it's just a file that points to this commit. And correct then changes head to point to feature. All right. So main is pointing to the correct commit. Head is pointing to the correct branch. What do we have left? Right, we need feature to point to a newly created commit. And the state of the newly created commit is actually the state that we currently have in the index, right? Because our index, after using git reset minus minus soft, the index matches the state of what used to be head before. So all I need to do now is git commit minus m, let's say 3.1. It's a different commit object because it has a different timestamp, correct? And I created a new object. And what else is going to happen since I used git commit? Right, feature will point to the newly created commit. Wasn't so hard, right? No need to panic. We made something by mistake. We're going to change history. Super easy. I wish it were that easy in real life. OK, cool. So now that we're happy, another challenge. That's a developer's life. OK, so what am I going to do now? So I'll add some changes into love.txt. Love changes over time. And I'm going to echo git is cool to a new file called cool.txt. So these are two changes. Now, one of the advantages of using the index is that I can stage one of them and not the other if I want to, right? But in this case, I staged love.txt and I staged cool.txt. I could have used git add minus capital A or dot to do all of that, but I want to be really explicit to be sure we understand what's happening. So the staging area currently has the change to love.txt, and it also includes cool.txt. And I'm reckless today. I committed. And I created a new commit object, right? And the pointer changed. But actually, I wanted them to be in two separate commits for the beauty of history and have atomic changes. Some people think it's really important. Some people don't. If you want, let's talk about it afterwards. But for now, we created one commit where we should have created two separate commits. OK, what can we do? Reset, correct, some reset. Which one would be easiest, perhaps?
Mixed.
OK, mixed. We could use mixed, right? If I use soft, it would mean that both changes are staged, and I need to unstage one of them. It is possible. Another way, which I think is more straightforward here, would be to use git reset minus minus mixed, which means, again, first thing that git reset minus minus mixed does is correct, change whatever head is pointing to. This time it's not main, it's the feature branch, right? Point to the parent, correct. And the second thing it does is change the index to match the state of head. So the index will no longer include those two changes, but they are both still in my file system. So now if I only stage love.txt, I can commit this change. And now I want to create another commit. It would be as simple as staging the other file cool.txt and committing it, which means we have a new commit object and feature points to that commit. Any questions so far? As you can see, git reset is really cool. Once we understand how to use it, it's really, really powerful. OK. We can be happy for a moment. That's enough. So now this is the current state. It's a different repository. We have head pointing to main, pointing to a few commits, OK? And now I created a new file called newfile.txt. And I created some more text into love.txt. And I staged both of them, this time using the git add dot. And I committed that, as in more changes. So I have a new commit object, and main points to this new commit object. Any guesses what's going to happen now? Oops. OK, so this time I wanted it in another branch, but not a new branch, but rather an already existing branch. Happened to anyone before? Yeah? Okay. So what do we do? I'll give you a hint. The answer is really short and really easy. What do we do first? One word. Not reset. Before reset. Before checkout. Draw. Correct. We draw. That's the first thing to do. It will make everything else so much easier. So this is the current state. I committed to main, and I'm embarrassed. And I have the newly created commit on main. Sometime in history, main branched to another existing branch, correct? And I want another state. What is the desired state? I want main to point to, right, the parent of this commit. I called it master here. Damn. Okay, my bad. It's supposed to be main, sorry. So this is main, existing pointing to the newly created commit, and head pointing to the existing one, right? Okay, so how do we do that? How do we get from the current state to the desired state? What would be easiest? So one way would be to use git reset, as we did before. But there is another way, because what I'm trying to achieve here, thinking about it, is I'm trying to take the changes introduced here, right, in this commit, and basically copy-paste them or cut-paste them to another branch. And Git has a tool just for that. You could use git reset, but I want us to learn another tool. So what we would need to do is first switch branches to the existing branch. How do we do that in Git? Git checkout or git switch. It's the same, correct? Git switch existing or git checkout existing, which moves head to point to existing. And now what I want to say is please take the changes introduced between this commit and its parent commit and just apply these changes here. So for that, there is a Git command called git cherry pick. It cherry picks the changes in this cherry commit and picks them and moves them to this branch that is applies those changes to the state of the active branch. So if this is the SHA-1 value corresponding to the latest commit on main, I'm actually going to take these changes. I could have also used git cherry pick main because it's pointing here, but I'm trying to be explicit, right? We could also use git cherry pick and take this commit, which would take the difference between the commit and its parent, okay? So we take those changes and apply them here. Git cherry pick applies these changes and does another thing. You have a guess? Similar to commit. Sorry? Correct, moves the existing branch, the pointer, to point to the newly created commit. It's like using git commit, just it takes the changes introduced in another commit. Very useful tool sometimes. Question?
Does the command reset those changes in main?
No, it doesn't reset those changes in main, so we're not done yet, right? Main still points to this commit. Remember that we could use git cherry pick for this commit, for example, right? So we wouldn't want any changes to main. But in our case, we do want, because we don't want to change main, right? So what do we do now? We want main to point here, remember? Switch back to main. So let's switch to main, which means what am I going to change here if I use git switch main now? Right, correct. The head pointer is now pointing to main. And what can we use now? Right, our beloved git reset, minus minus, hard, correct. So I'm using git reset hard to head tilde 1. And this is exactly the state we wanted to achieve, right? Existing pointing to a commit that includes the changes we introduced to main beforehand. Head points to main, pointing to the previous commit. Any questions about that? Yes? Yes, the commit shot changes for a few reasons. First and foremost, or more accurately, always, the timestamp changes, right? Because I committed it now. Another thing that may change is the author, because this commit may have been created by you, and now I cherry-picked. Another change is that it may actually point to a different tree because the state here and the state here may be different, and thus the state of this file system that the commit here points to may be different than the state of the tree that this commit points to, right? But it may not. Right, it actually computes the difference between this commit and that commit, and then applies them on this state, which also means that sometimes it won't be able to apply those changes. You may get a conflict, but that's a topic for another call. Okay? Awesome. Any other questions so far? We have acquired a new tool. So we have git reset and git cherry pick. Okay, so another day, another repo, another problem. Head is pointing to main, and I created some more text, and I staged it. I committed it, so I have a new commit object, right? Main is also changed. It moves to the newly created commit, and now I pushed. This is not something we've done so far, right? But now that I pushed, I noticed something. I made a mistake here, right? There is a typo there. I wrote this is more test instead of this is more text. Whoops. So what's the big problem now? We pushed. We pushed, which means that someone else might have already pulled those changes, right? And now I may have one version of main. That other person would have another version of main. If I override those changes by using git reset, as we've done so far, and I rewrite history, we will have different histories, and all hell might break loose. Okay, this is not a good position to be. You can rewrite your own copy of the repo as much as you like until you push it. Once you push the changes, you need to be very, very, very certain no one else has fetched those changes. Or we may better find a different solution here. Okay, so what do you suggest? I want to undo this change, but in a way that makes sense. Yeah.
Revert.
Okay, cool. So we could use another tool called Git Revert. What Git Revert does is take the commit I'm asking it to take. In this case, it's just head. Okay? Compute the diff from the previous commit, just like we did with Git cherry pick, but this time it computes the reverse changes. So if here I added a line, the reverse would mean delete the line. If I deleted the line, the reverse would mean adding that line. And it creates a new commit object. The state in this commit object is going to be just the same as this one, right? Different timestamp, different parent. Yet, it's a new commit object, which means it's an addition to the history. It's not another history. I didn't rewrite history. I added to the history. I admitted my past mistake, okay, and pushed an acknowledgement that I made a mistake and now I fixed it. Some would say it's the more mature way. Some would say it's not as clean a history as if we had used git reset here. But we don't really have a choice. In this case, we have to use something. We could git revert. We could just not revert, but rather write text and override that, right? That's also fine. But the explicit way would be to say, I want to undo by introducing another commit, saying I undid this change. And now I can, of course, create this is more text, stage, and commit it. So it's a longer commit history, right? Mistake, undoing the mistake, correct version. If we had used git reset, it would be just correct version. But we can't use it once we pushed. Now we can push with confidence. Any questions about that? Yes, please.
So I forked a repo through Stack Overflow to my GitHub, and then I downloaded it to my server, changed it. When I went back, it had this weird history thing, and I just pushed, like force pushed it.
Okay, when you force push, it basically means whatever's going on in there, just throw it away, use my history instead. So you could do that. If I were here, if I used git reset, and I would push force to the server, it would mean the server would get main pointing to a different commit. But the problem is that someone else working on this repo may have already pulled another version, right? And then we're working with different versions. And this is a problem. So technically, I could push force here. It would work. It's just not something that I would recommend doing if I were to work with other people.
So if somebody else changed the history, were they changing it on the original from Stack Overflow?
So it depends if they fetched it.
Or on my repo on GitHub?
So it depends on that case, if they fetched the version that you pushed, or they already had a local copy, or they worked from a different copy. And since we don't know, what I usually almost always recommend doing is avoid force pushing. Unless you're working on your own branch, you know, no one else will ever work on this branch. Okay? All right. So we're happy again, which means we need to find a worse scenario to tackle. So this is our new toolbox now. It has git reset, git cherry pick, and git revert. And now I'm working. I created a lot of work, put it into love.txt. I staged it, I committed it, so now I have a new commit object. And I used the up arrow key. Do you guys ever do that? To go back in history in the command line? And then I hit enter. Oops. What did I just do? So I deleted this commit, but what actually happened? I used git reset minus hard, which means I moved the pointer here, right, back to head tilde 1, so it's not reachable from the current history. I also unstaged all the changes to the staging area, and then I matched the working dir to the state of the staging area. That is, everything matches this state. All of my changes are gone. Freak out time? Freaking out? Yeah? No? We're relaxed. We're relaxed people. What do we do? Well, intuitively, is it really, really, really gone? No. Why not? Because I didn't push? Well, if I had pushed, it would have still not been completely gone. It's somewhere, right? It's somewhere. What is this somewhere? You're kind of... Right, but it's inside the internal database of Git. Somewhere, we don't know where. If I only knew where, that is, I would know the what? The hash, the SHA-1 value that identifies this commit, what could I do? Git log, sure, but even more than that. I could check out, correct, or if I could I just want main to point back to this commit. I want to undo the undoing.
So maybe you would go git log, and then once you find the object number of the commit, you would reset to that.
Okay, so git log, we'll talk about it in a sec, but if I had the commit SHA, I could just git reset minus hard to that commit SHA, which would mean the pointer of main would point here, the staging area would be the same, and the index, the staging area would be the same, and the working dir would be the same, right? It would point back to this commit and so on. So the only thing I really need here is the commit SHA of the deleted commit. Does that make sense? Okay, so the question is, how do I find it? And the problem with using git log now is that if I use git log, head, right? Git log will go to head, will go to main, will go to this commit, and then trace back through the parent chain. So this one is really not traceable, not reachable via the history. So what do I do? So to get things more interesting, this time I want us to hurt. So I want to actually do this. So I have a simple Git repo here. Let's use Git. It's really hard with the microphone in one hand, sorry. Git log. Very interesting history, right? Okay, cool. So we have commit 2 and commit 1. And let's write some changes. So I'll put this down for a sec. I'll try to scream. Do you guys hear me? Good. So echo. Oh, cool. I already have all you need is love. Nice. And let's echo code and coffee is awesome into awesome.txt. And let's add that, commit 3. And let's clear, so I don't see the SHA-1 value. OK? And let's use git reset hard head tilde 1 and git log. All right. So what are we going to do now? Thankfully, the very smart people who created Git have a backup plan for us. And that is called the reflog. So while we work with Git, whenever we change head, which means we could do that by using git reset, but also other commands like git log doesn't change head. What changes head? Git checkout, switch, commit, right? When this command change head, git reflog remembers the changes introduced. So what we see now is that we used git reset, moving to head tilde 1. We're now pointing to 8b, 6d, and so on. But before that, head was pointing to commit 3 with this SHA-1 value. And before that, there was another reset here, apparently sometime in time, another reset. Here we can see it pointed to commit 2. Once it was committed, another commit 3 back in time. So what I could do now is git reset to this commit SHA. Another thing we could use is git log -g. -g uses the reflog. So instead of just git logging, it logs via the reflog. So what the reflog currently points to is commit 2, right? But its parent in the reflog, that is what head used to point to beforehand, is now commit 3, exactly what I wanted. Which means, to go back in time, I can just take this commit SHA, git reset hard, and this commit SHA, and we save the day back to before. I might have also been able to do another thing. Let's do it again. Git reset hard. 1. So if I use git reflog, I will also see that this stage of before head has a nickname. The nickname is head at curly brackets 1, right? So like we use head tilde 1 to go to the parent of head, if you use head at curly brackets 1, we go to the reflog parent of head. Which means, if I look at git rev parse, which tells me the actual thing something points to, so git rev parse head gives me the SHA-1 value that head is currently pointing to. Just git rev parse head at 1, I get the SHA-1 value of what head used to point to before the reset, which is commit 3. Which means I could also do git reset hard head at 1, back to commit 3. If I do it again, what's going to happen? So this says resets the state to the state of what head used to point to before the last command. Where did head point to before the last command? Commit 2. I'm at commit 2. I want to go back to commit 3. I could go on all day. Not that hard after all, right? I mean, git reset hard, but not hard. All right. Any questions about using reflog? Yes.
The difference between reflog and log-g is that does the -g just give us more like readable interface?
Exactly. Log-g is, it looks like git log, but it goes through the entries you would get from git reflog, just outputs the entire information in the commit objects. Okay? Any other questions? Yes?
So I guess like if we were, for example, not committing, we just like checked out to a new branch and
Yes.
did this hard at one thing, would that just switch us back to the branch?
So let's do that, right? Git checkout -b this time. Before that, we switch -c, right? It's the same. my new branch. So head now points to my new branch, right? What's going to happen?
Resets back to the old branch.
Right, to commit 3, and if I use git log, it's still commit 3, right? Because what it used to be, even beforehand. If I want to go even back, I could use head at 2. Still commit 3. Why is that? I don't know, so let's use the git reflog. What do we see here? We can see that head kept pointing to right. I kept moving it from commit 3 to commit 3 to commit 3 to commit 3. So it kept adding more and more entries, like so, in the reflog. So to go all the way back now, I need to go to head at 4 at this time. So I wouldn't advise working like that most of the time, right? It's not the most convenient thing to do, but it is quite useful when all hell breaks loose. Okay, other questions about that? Yes?
I don't know if this is unrelated or not, but I was working one time, I got into something called detached head.
Yeah, so detached head means that head is pointing to a commit object directly
Okay.
and not to a branch. This could happen in different cases, and you could just check out from that, or it depends on the case. Okay? Cool. So I would also say that now we have another tool, git reflog, and its sibling, git log -g. And all in all, we have 5 different tools. I'd also say that I was really thinking, contemplating whether I should cover another important tool called git rebase, but I felt like this is quite enough for one session. I think that with these tools, you now better understand how Git works. And I would also recommend, if anyone is interested, I have many more tutorials on my YouTube channel. You're welcome to reach out to me for more information afterwards. And you can keep from that. Now, moving forward to Git rebase will mean much more to you after you have acquired these tools. So basically, with these 5 tools, you can undo almost anything in Git, or actually anything, but with more work than might be required with other tools. But you can really undo everything that might happen. So what did we do? As I promised, we did better understand Git internals, right? We understand how Git works better. Again, if you're interested in learning more, I have more talks about it. You're welcome to talk to me about it later as well. We also acquired some useful tools and commands, specifically those 5 I marked before. And again, I'll stress it out. Git reset is the most useful one, probably. After the most useful one, which is drawing out things. Okay? After you draw things, you can use git reset to fix almost anything. We improved our intuitions regarding Git, right? It's not so scary. It's just pointers moving around. That's it. It's a pointer. You need to change where it points to. That's it. Sometimes it's a bit scary because you did work on something more than a sec on the whiteboard, but I don't know, it was a week of work. But still, it's something you can change. And we had fun, right? And again, the most important thing, just draw this out. Trust me, whiteboarding this makes things so much clearer. I know on this whiteboard, on the screen, it seems easy when someone else does it. When you draw this out, work through the changes slowly, you'll know what you need to do. And you can practice. Follow, I'll share the slides as well afterwards. You're welcome to try it out yourself. Delete some of your most important work. Then undo that. Any legal advisors here about the last comment? OK, never mind. So we did have much fun, acquired some new tools, and I hope you will feel more confident working with Git from now on. Thank you so much for listening.